Bearing selection. We will apply bearing selection techniques to determine the radial and axial loads, shaft speed, and the lifespan of bearing based on the design specification. Okay, that means based on what is the customer needs, calculate the required loading. Then from there you select the standard bearing from the manufacturer catalog. Alright, so various question will come with different form of radial or axial loading or both, and various shaft speed and bearing life. So what is bearing life? Bearing life is termed as a number of revolution or hours of operation at constant speed required for the failure to occur or develop. So bearing life is either termed as in terms of revolution or in terms of hour failure. So when you see a rating life called L10, L represent life 10. So what does this mean for bearing rating life L10? It's actually referring to the number of revolutions, okay, or hours at a uniform speed that 90% of a group of identical roller bearing, similar bore diameter, similar number, example 6205. Then they run through the bearing and 90% of it should complete or exceed the number of revolution before the first evidence of fatigue develops. Example, this particular bearing manufacturer, in order for them to know their reliability of the bearings they manufacture, they do a lab test on that 10 bearings. Okay, all the 10 bearings are set on a similar condition, uniform speed, and similar loading of maybe axial load or radial loading condition, and they rotate at 1 million revolution. And assuming the bearing supposed to operate at 1 million revolution till it failed. So based on the L10 criteria, 9 bearings should exceed that 1 million revolution. Maybe the failure will start, failure to develop will start after 1 million revolution. And that particular one bearing may fail before 1 million. So, and this is how they quantify their quality. Of course, you can have a L1. L1 will be more stringent, where you have, instead of 10, then I use 100 base. 100 of bearings being set on that condition, uniform speed, same loading, 1 million revolution. 99 would fail beyond 1 million, and 1 will fail before. So if you have L50, then your quality is quite bad, because out of that 50% will fail prematurely. And if it's a L90, then nobody want to buy, because to replace the bearing will require production stoppage and time wastage, and time is money. So of course you can have L0, that means 100% won't fail, and that's very expensive. And the cost of manufacturing that bearing and the guarantee of bearing failure process will be very expensive, and I don't think anybody will purchase the type of bearing. So there's always a balance. So L10 is quite common. All right, let's move on. So this is the typical L10 rating and equation given to calculate that. So let's run through this. Please remember this formula, because it will not be given in your test. But then again, because of this COVID-19, this is the open book test, so we can always come back and refer to the formula. So how do they achieve this formula, is actually obtained by testing and statistically analysis. So L10 refer to bearing rated life, is in under revolutions to failure in this case. Later we talk more about hours. Okay, let's referring to now L10. When you see L10, is always revolution failure. I mean L10. Okay, CR. Okay, CR referring to basic dynamic load rating. Okay, where is in kilonewton, 90% reliability. So you will need to based on, let's say your criteria. If you are the factory owner, you want to purchase a set of bearing. So it will depends on what type of how many revolution you want, what is the loading applied onto that bearing. Okay, the PR. PR is actually your loading. That means, let's say example, if you want to put a bearing to drive a van or motor, then the motor weight at certain uh, kilogram. So that will be your PR, your loading. That means factory load. So from there, you will actually able to calculate what is your CR. Okay, and then when you calculate your CR, which is your dynamic loading, that is your factory dynamic loading. Then you go to the catalog and compare and search for that particular bearing that work under that condition. In other words, very simple example would be purchasing a shoe. So your everybody have their own set of standard requirement. Example, let's say running shoe, there's various brand, and then some people will look at design, some people look at sizes available, pricing, all that. So same thing for bearing. Yes, you are supposed to select the bearing because of cost. If not, you can just purchase offset the most expensive bearing that will last beyond, but you're wasting your money. All right. Then K itself will be the exponent, which is if it's a ball bearing, your K value will be 3. Okay, Bluetooth take note of that. And if it's roller bearing, if you are calculate rating life for roller bearing, then the K is 10/3. So times 10 to the 6 revolution. Okay. So let's move on. Uh, so this is a CR we refer to is a basic dynamic load rating, where it is that constant stationary radial load which a group of apparently identical bearing with a stationary outer bearing can endure for a rating life of 1 million revolution. That means you will go to your appendix bearing catalog, you will see actually there is a basic load rating and Newton in Newton and a CR. So in other words, when the particular manufacturer they manufacture this example 6800, okay, bearing number. I hope you remember what's 00 refer to. Remember the 00010203. They are supposed to read directly on the chart what is the ball diameter. So 00 will be, I can't remember, also can refer. Okay, 6800 particular bearing. Then they applied 1410 CR. Okay, they apply this loading onto this bearing 6800 in this case, and they rotate it. And by right, if let's say it's L10, then out of that 10 bearing they rotate, one will fail before 1 million. Then the rest will start to have failure occurrence after 1 million revolution. This is what they're trying to say. So for you, the previous formula, L10 is equal to CR over PR to the power of K times 10 to the power 6. Actually, that CR you're going to calculate. It's called CR calculate. You calculate based on the type of loading you have in your factory, how many revolution you want. Then from there you calculate and based on the CR on the catalog. Example, if you calculated you need based on this ball diameter 00, your CR you calculated is 2000. Then you may want to use 6900. Why? Because 6900 the CR is 2070. So it does able to accept that loading. If you were to use 1410, which is 6800 bearing, then your uh, selected bearing will fail prematurely due to the loading differences. Okay, so this is what we do. Actually, the overall thing is you are supposed to calculate the required CR and compare to the catalog based on the ball diameter. Okay, and you select the calculated CR, the catalog CR to be greater than that. So in other words, if you say you measure your shoe size is size 10 and or 10.1 US size, so you won't purchase a size 9 or size 9.5 because you know that size 9 or size 9.5 US will give you a very cramp, painful and tight fitting. So you will of course purchase something 10 or 10.5 US size. So it's quite similar to that also. All right, let's move on. So PR here is referring to dynamic equivalent bearing load. So this PR normally I would say is your needs, your factory loading. I always use it at factory loading. That means it's what your factory setting, and then it's a constant stationary radial load that gives the same life as the bearing would attain under both radial and axial load. Okay, if it's radial load, it's still PR. If it's a combination of axial load, it's also PR. But it's just that your PR won't be so you won't obtain the reading directly. If it's a radial and axial loading, you will have a formula to fulfill and a table and charge to fulfill, which we will run through for the example. But if it's just a radial loading, your FI is actually your PR. And then from there, that's why I say that is your factory loading. Okay, that FI is your factory loading. Okay, what is the loading on that? Then you calculate your CR based on this PR, then you go and refer to catalog. Okay, you understand more when we do the example, right? Okay, so this is coming back to the same thing again, static load rating CO, the load that will produce permanent distortion of the rolling element or raised element. So this is just another term given like static load rating and ultimate loading. Okay, so these slides. Okay, so L10 must know, and we will always use this. There are two methods to calculate your L10 and obtain your CR and select the appropriate bearing. One is through this equation, the other one is nomograph. So we will have example running through using these two methods approach, nomograph or equation. All right. So given to that will be L10 is equal to CR over PR to the power of K. That's a rating life in 10 of 6 revolution million. So rating life in revolution, right? Per revolution would be L10. You just multiply by a million. So yeah. Then if remember this is per revolution by revolution, 1 million revolution failure, L10. So you see at L10H is actually referring to the failure in terms of hour. Okay, remember your L10 rating life for bearing can fail in terms of revolution. By 1 million revolution, it will fail, or in terms of operating hours. Right? It's quite similar to engine, car engine oil or motorbike engine oil replacement timing. It's either 10,000 kilometer or 6 months. So it's quite similar. It's either 1 million or by the hours you should fail. And this calculation will allow you to uh, stop the production and replace the bearing before a catastrophic failure occurred. All right. So by knowing my L10H, right, actually I know that before it reach the required hours, I will stop my production, remove the bearing and replace a new bearing. If not, if you run through it, then the bearing will fail, disintegrate or cease, and my whole system, okay, may have a catastrophic failure. So L10H is equal to 10 to the power 6 over 60N, where CRPR to the power K, where N is given to your RPM. So given here, L10 revolution, how do I get my L10 revolution if I given by the hour is L10H, right, times RPM times 60 convert it to RPH. Then you multiply by H, then you will get a revolution. Okay, so I mentioned earlier, how do we select the bearing? We need to calculate the CR. Okay, the dynamic load rating required, that means your factory CR. Then you compare it and with the catalog. Okay, so when you do this, this is actually a conversion from here. Conversion. You make it a CR as the main, so you have PR open bracket L10 divided by 10 to the power 6 1 over K from here. So and when you calculated your CR, you compare it to the catalog, you choose the catalog number greater than the calculated. All right. So this is what the formula is about. So I mentioned earlier there we have two methods to obtain a CR. One is using equation, all right. The other one is using nomograph, which is from your appendix page A1, A3-1, sorry. Yeah, this is the appendix. So live equation for using nomograph is FH, you go to Fn times CR over PR. This one I'll explain to you later part, but this is the equation that we introduced earlier. All right, so there are two methods. Okay, next video we will talk about examples and using the examples to show you the calculation and selection of appropriate bearings.